we have a binary tree, and we want to list out its values in a specific order. Preorder means at every node, we deal with the node itself first, then everything in its left subtree, then everything in its right subtree. Root first. That is what pre means. Let's see what order that gives on our little tree. The trick is recursion. To do a preorder of any node, we first output that node's own value. Then we run the very same preorder on its left child, which handles the whole left subtree. Then we run preorder on its right child for the whole right subtree. The base case is an empty node where there's nothing to do, so we just stop. Because we always dive into a child before moving on. This is a depth first walk. On our tree, it gives 1, 2, 4, 5, 3. If the node is empty, there is nothing to visit, so we return an empty list. Otherwise, we build the answer as this node's value, followed by the full preorder of its left child, followed by the full preorder of its right child. The recursion takes care of every level for us. Let's write preorder in the editor and run it on our sample tree. First, the base case. An empty node has nothing to visit, so we return an empty list. Otherwise, this node's value first, then the whole left subtree, then the whole right subtree. Now, let's test it and hit run. And there is the order 1, 2, 4, 5, 3. We took the root first, then dived left into 2 and its children, and only then came back up and out to 3 on the right. Here is the shape of one visit. If the node is empty, we stop. Otherwise, we output its value first, then recurse into the left child, then recurse into the right child. Root, left, right, every single time. We touch every node exactly once, so the time is order n for n nodes. The extra space is the recursion stack, which is as deep as the tree is tall, so order h where h is the height of the tree. 3 reminders. First, always handle the empty node first, otherwise the recursion has no way to stop. Second, the order is fixed. Value, then left, then right, and swapping any 2 gives a completely different traversal. And third, for a tall lopsided tree, the recursion stack can grow deep, so keep that in mind.